Hello guys, my name is Utkarsh Gupta and today with us we have Bhavya who is an ICPC World Finalist this year. Before that, let's Bhavya please introduce yourself.
So, hi everyone. I am Bhavesh Jain. I am undergraduate of IIT BHU Computer Science and Engineering. I interned at Microsoft and I'll soon be joining Microsoft Redmond as a full-time employee. Also, I qualified for ICPC World Finals this year.
Alright, so you might have heard of Fibonacci numbers, right?
Yeah.
Fibonacci numbers go like this. F of I equal to F of I minus 1 plus F of I minus 2 for I greater than 1 and F of I is equal to I for 0 and 1. So let's modify it a little bit. So currently, let's say we are saying f of 0 is equal to some random number a. We will give this in the input. And f of 1 is equal to some random number b. We will also give this in input. Alright. Define a series S of I, which is basically summation of first I Fibonacci numbers. So f of 0 plus f of 1 plus f of 2 up till f of I. And let's define another series that is SSI, which is summation of first SI term. S of 1 plus S of 2 plus up till S of I. So for any given input n, so given inputs will be A and B, which are the initial values of the Fibonacci numbers, and in value n. We have to find the value of SS of n. So is the question clear to you?
Yeah, I guess. Yeah. So, I'm assuming n is greater than or equal to 0 because that's what Fibonacci is defined for.
Yes, exactly. So n will always be a natural number.
So, we know that Fibonacci series may go exponential, so the sum may also go exponential. So,
yes,
how to store that?
Very good. So, in case we have bigger values of Fibonacci numbers and similarly S of I or S of I, we are taking mod. So, let's define a mod like 10 to the power 9 plus 7. So, you have to return the value of S of n mod capital N. Let's say M is our mod.
So, a naive approach would be to calculate all the Fibonacci series, then calculate the prefix sum of the Fibonacci series, which will give us S, and then calculate another prefix sum, which will give us S of n.
Alright.
So, let's say Fibonacci is X, Y, the first two terms are A and B. So, A, B.
Let's take some input. I mean, let's say A is equal to 1 and let's say B is equal to 1.
So yeah, the standard Fibonacci series 1, 1, 2, 3, 5, 8, 13. And if we can go on calculating this. Then we will store the prefix sum, which will be 1, 3, 1, 2, 4, and so on, 7. Then we can store another prefix sum, which will be 1, 3, 7, 14. And we will go on doing this till n, and we will find and we also will take mod so that there is no overflow.
Yes,
and that will give us the nth number in the series S of S. SS.
Right, very good. Can we start with the code of that part first?
Okay. So I'm assuming the bounds on A are like n are 10 to the power 5 or something.
I mean, let's start and then later on we will discuss the complexity part. So, just assume you have a function in which you are given inputs A, B, and M.
N, A, and B.
Yes. And we have to return n, S of n, modulus n.
So let's make three arrays, vector int f of size n, s of size n, and ss of size n. We know that f of 0 is A, f of 1 is B. Also, we can see that it follows the relation S of I is S of I minus 1 plus f of I, because since it is the prefix sum. Or actually we can store the prefix sum directly. So let's first calculate f. For 2 to n, f of I will be f of I minus 1 plus f of I minus 2 mod. And since these are both less than 10 to the power 9 plus 7, then the sum will at most be 2 into mod minus 2, which will be in the limits of integers. So there won't be any overflow issues.
Right.
Now, S of 0 is f of 0. And since we need to find perfect sum, so let's loop from 1 to n. And we know that S of I is equal to S of I minus 1 plus f of I mod. Because S of I is the sum of first I numbers, and if we know the sum of first I minus 1 numbers, we can just take the ith number and add it to the first I minus 1 numbers to get the sum of first I numbers.
Yes, perfect.
Using a similar argument, we can do SS of 0 is S of 0, and let's try to find SS of I similarly. SS of I plus S of I using the similar argument, and actually we need to find the nth number, so loop till n, and then we should return S of n.
So will it find right?
Yeah.
Okay, very good. What is the time and space complexity of your program?
So we are looping over n thrice. So in the terms of big O, it should be big O of n. And we require arrays of size n as well. So space complexity will also be on.
Correct. So time is order of n and space is order of n, right?
Yeah.
Can we optimize on the time or the space complexity?
Okay. We see that Fibonacci only depends on the previous two numbers, and also the sum only depends on the last number. So we can somehow store the previous 2 or 1 values to eliminate this array. Let's call F0 I1, which will denote the Fi minus 1th number initially, and Fi2, which is Fi minus 2. So initially, Fi minus 2 should be A, Fi1 should be B. So for 2 to n, let's calculate current F. Current F will be the sum of f of 1 plus f of 2. Let's calculate S and F simultaneously, S, SS, and F, because we are not storing anything. So S of I is X, SS of I, actually it is for 2. So SS of 1 should be X plus Y, because it's X, Y, A plus B, sorry, A and B, A plus B. And SS of I should be A plus B, 2A plus B. So current is F1 plus F2. Now let's date F1 and F2 as well. So now Fi minus 1 will be current after this operation, and F2 will be F of 1, because this was F2, this was F1, and now this is current. After the next operation, this will become F2 and this will become F1. So F1 is current and F2 is equal to F1. Now let's try to calculate S of I. So S of I should be S of I plus current F, and SS of I should be SS of I plus S of I. And since we need to find nth number, we'll return SSI. So this should return the nth sum, nth term of the series S of S.
Okay. Anything which you feel can go wrong in this?
Okay. So our initial series is A, B, A plus B, 2A plus B. This is our F, and S should be A plus B, 2 into A plus 2 into B, and so on. And then it should be A into A plus B. So I've initialized it correctly. And current will be the sum of Fi minus 1 and Fi minus 2. F of I minus 1, since we are updating it for the next term, it should be current, and F of 2, Fi minus 2 should be F of 1. So we should return S of I. Logically, I don't see an issue.
One small mistake is there, and 2 small mistakes I can say. Just try and see.
Okay. I minus 2 is A, F of I minus 1 is B, S of I is A plus B to. Okay, yeah. So yeah, let's just take mod. This should be mod here. And now let's just assume that all the operations we are doing are under this modulo.
Okay.
So all the sum and multiplication are under this modulo, mod 10 raised to 9 plus 7.
One small mistake is still there, I can say. I mean, just try and see.
Okay, defining current.
And don't worry about the capital and small cases.
Yeah, Google Doc automatically does it. So
yeah, it's okay. It's okay. One logical mistake is there, one small logical mistake. Just try and observe.
Okay. So are the initialized values correct, right? S of I is 2A plus B.
Any hints? Any help?
Yeah.
F1 equal to current F should be above, should be below F2 equal to F1. Reason is, once you have updated current F, you are initializing current F to F1, and that current F is again added to F2. I mean, F2 is also equal to current F now. Because of this, all the three parameters are equal. So we are keeping using a track of previous.
Keep it here. F2 equal to F.
Yes, correct.
F2 equal to F1, yeah.
Very good. One more small thing, I mean, please observe.
Oh, I think this is correct because this is the sum of previous two values, and initially it is not even initialized anything, so it will be random value.
Current?
So I think the position of this is correct. This is the current value we are finding.
Yes, that is totally correct. One small thing still. Okay, can you explain this code again once, and maybe then we can observe.
So F2 is the Fi minus 2th value, F1 is Fi minus 1 value, Si is sum of the second value. Okay, so we need 0 first value because we are calculating from 2 to n. So this is the second value we are calculating. This should be A plus B, then 2A plus B, this is the initial value. Then this current F is the Fi, and also we are updating Fi minus 2 to Fi minus 1. And Fi minus 1 will be changed to Fi because this is the value which we will use for the next term.
Right, correct.
And then sum of I is the current sum plus the current F.
Correct.
And S of I will be the current sum plus S of I calculated trillion.
One small thing. I mean, if you observe, we mentioned in the start that n can be any value between 0 till larger. So we forgot to take care of n equal to 0, I think.
Okay, yeah. So for n equal to 0, for n equal to 0, it will return a wrong answer. For if n is 0, we can return A.
Yes, perfect. Now, what is our time complexity and space complexity?
So our time complexity should be On and space complexity should be O1.
Right. Is there any way to reduce time complexity?
So Fibonacci numbers follow a recurrence, and we can find the nth number in O of log n using matrix exponentiation. So if we can find a similar recurrence for S of S, then we can also do it in log n.
Okay. Can you explain how we find nth Fibonacci number in log n? Time.
Okay. So we know that Fibonacci numbers follow the recurrence f of I equal to f of I minus 1 plus f of I minus 2.
Right.
So let's try to represent it in terms of matrices. So this is f of I, this is f of I minus 1.
Right.
And let's try to represent it in terms of matrix with one difference. Okay, let's say this is a 2 cross 2 matrix which we will find now. And we are multiplying it by f of I minus 1 and f of I minus 2. We should place such numbers here so that this relation is followed. So looking at the matrix relation, we can place 1 and 1 here because 1 into f of I minus 1 plus 1 into f of I minus 2 should yield f of I.
Right, correct.
And we can place 1 and 0 here because 1 into f of I minus 1 is f of I minus 1, and we are then multiplying 0. Okay, so let's try to replace I by I minus 1 in the above equation. So what it should yield? F of I minus 1, f of I minus 2, and then the same thing, f of I minus 2, f of I minus 3. So let's replace this equation f of I minus, this is a vector matrix. So this is a matrix of dimension 2 cross 1. Okay, let's replace this column vector here. So we will see that we get a relation. Let's copy this here. This square into, so this should be f of I. When we replace here, we get f of I minus 1 is equal to square of this matrix into f of I minus 2, f of I minus 3. Okay, so we see that this is I minus 2 and this is square. The sum of these numbers is I, and same here. So this is matrix raised to 1 and this is I minus 1. So I minus 1 plus 1, this sum is I. And we can again replace I by I minus 1 and go on doing that. So in general, we will get a relation that this sum is I. So for f of n, let's say replace I by n. So f of n minus 1. Then this matrix raised to a power. Let's find the power afterwards. And we know the initial two values, f of 1 and f of 0.
Yes, correct.
Okay. So what should be the power so that the sum is n? Because we know that the sum is I here. So it should be n here. So we should raise to n minus 1. So this matrix 1, 1, 1, 0 raised to n minus 1 into f of 1, f of 0. This relation should also follow.
Yes, makes sense.
Okay. So all we need to do is find a matrix raised to a power.
Correct.
And we can do it using exponentiation. So let's say we want to find, we know that we can multiply two matrices, square matrices of order n in n cube.
Right.
Okay. So, and this is, since a matrix of 2 cross 2, we would require 8 operations, 2 cube operations. So let's try to find how we can raise a matrix to a power. So we can, so let's say if n is even, so n is even, we can write a raised to, we can write in terms of 2k if n is even. A raised to 2k should be a raised to k square, or a raised to k into a raised to k. Okay. So, and if it is odd, then let's just write it as a into a raised to 2k. So if we do it recursively, so if n is even, then we will find a raised to n by 2, and we will store that value and multiply the value stored by the same. So if we know a raised to k, we can multiply it by a raised to k and return that value. And if n is odd, then we can just multiply a and call a raised to 2k recursively. So we see that in every two operation, we will reduce n by 2. So if n is odd, then we will reduce it by 1, and if it is even, then we will divide it by 2. So if n is even, we will divide it by 2 in one operation, but if n is odd, we will subtract by 1 and then divide it by 2. So in the worst case, we are dividing it by 2 in two operations. So this will require 2 into log n operations to calculate a matrix power, like a matrix raised to a given power.
Can we code this part where you are like finding matrix raised to the power n minus 1?
Sure. So let's assume that A is a global matrix 1, 1, 1, 0, which we want to calculate, and mult AB is a function which returns a matrix C, which is the multiplication of A and B.
Okay.
So matrix is a class which contains the matrix. So matrix power matrix S comma int n. So if n is 0, we know that any matrix raised to 0 returns identity matrix. A raised to 0 equal to I, and identity matrix is 1, 0, 0, 1.
Alright. One question before we start. You mentioned A is a global matrix with 1 and 1 0, right?
Yeah.
So what is this S matrix?
So this we will pass it as a function. So we will
Okay.
pass matrix a comma n.
We can just say it's a matrix.
Yeah.
Okay.
So we will return I. I is again, let's say, global matrix 1 0 0 1.
Okay.
And if n is odd, n and 1, we can return mult. So we will multiply a by power a. Actually, we don't need s, I guess, because if we are multiplying it, so mult a raised to n minus 1, power n minus 1. And if it is even, then calculate mult n by 2. So let's say it is a matrix B. Return mult B comma B.
What is this mult function? It's a mult is
It returns the multiplication of two matrices.
okay, but here we are not passing to matrix.
Oh, so sorry. This is power. So we will find a raised to n by 2 and then multiply it.
All right. Can we see a simple diagram like using, let's say, n equal to 6?
Okay, n equal to 6. So we need to calculate a raised to 6. So we will first call, since we see 6 is even, we will call power a cube, power 3. So to calculate a cube, we see that it is odd. So we will calculate a square, right? Again, it is even. So we will call a raised to 1. Again, this is odd. So we will calculate a raised to 0, which and we reach the base case, which is 0. So we'll return iota, identity matrix, and then we'll go up and above. So we'll multiply a by a raised to 0, and we will get a. Then we will multiply a by a, and we'll get a square. Then we will multiply a square by a, and we will get a cube. Then we will square a cube, and we will get a raised to 6. We will call this function mult BB.
Correct. And as you explained, diagonal lecture will be order of log n, right?
Order of log n. Yeah.
Okay. So using this, like as you explained, based on the matrices, we will be able to find f of n, like n Fibonacci term. Can we find s of n using the same theory?
So, like if we can find a similar recurrence for s of n, then we can find it. So let's say we know this recurrence f of I equal to f of I minus 1 plus f of I minus 2, and s of I is f of I minus 1 plus f of I. So we want a recurrence in s. Let's try to express f in terms of s and then replace here. So we know that f of I should be s of I minus s of I minus 1, right? So let's replace f of I here in this recurrence. So f of I is s of I minus s of I minus 1, which should be equal to f of I minus 1, and f of I minus 1 is equal to s of I minus 1 minus s of I minus 2. Again, f of I minus 2 should be equal to s of I minus 2 minus s of I minus 3. And let's try to recollect terms. So s of I should be 2 into s of I minus 1. And this will get cancelled, and minus s into s of I minus 3.
Yes.
So we found a relation for s. But we also need to find a relation for ss. Also, s of s, we know that satisfies this relation. S of I is equal to ss of I minus 1 plus s of I. So we can do similar thing like we did here and produce a series. So let's say call it 1, and s of I is equal to ssi minus ssi minus 1. So replace this in the equation 1.
This is equation 1, right? Just so that you don't have to.
Yeah. So ss of I minus ss of I minus 1 this should be equal to 2 into SS of I minus 1, and SS of I minus 1 is equal to SS of I minus 1 minus SS of I minus 2. And then we will subtract it by S of I minus 3. S of I minus 3 should be equal to SS of I minus 3 minus SS of I minus 4. So let's try to collect terms to one side, and we will see that SS of I will be, let's try to find the coefficient of SS of I minus 1. This should be equal to 2 plus 1, 3. So 3 into SS of I minus 1. Try to find the coefficient of I minus 2, and that should be minus 2. So minus 2 into SS of I minus 2. And let's try to find the coefficient of SS of I minus 3. So SS of I minus 3 should be minus 1. SS I minus 3, and I minus 4 should be plus 1. So SS of I minus 4. So we found this recurrence. So let's try to do a similar thing as we did here, finding a matrix so that we can find a relation raised to some power. Okay, so let's try to build a matrix for this. I guess I'm going to use tables here too. Let's merge here.
Oh, nice.
You don't need this actually, but yeah, that's fine. Yeah, this is the final equation we want to represent in terms of a matrix. Okay, so also let's merge this as well. Again, we will do the same thing. Represent S of I, SS I minus 1, SS I minus 2, SS I minus 3, and we will find it by difference of 1. So SS I minus 1, SS I minus 2, SS I minus 3, and this should be SS I minus 4.
If we observe the above one in the Fibonacci sequence, we took two terms, like f of I and f of n minus 1. Here we are taking 4. Can you explain why is that?
Can you repeat?
We are taking 4 terms over here and only 2 terms above.
So the basic difference is because that was a 2-degree recurrence. So it only depended on the last 2 terms. And here we can see that it depends on the last 4 terms. So to represent SSI, we need SSI minus 1, SSI minus 2, SSI minus 3, and SSI minus 4.
Yes, correct.
Okay, so so it's a 4-degree recurrence, so we will require a matrix of 4 cross 4. So let's try to find the coefficients. So we know that SSI is equal to 3 into SSI minus 1, minus 2 into SSI minus 2, minus 1 into SSI minus 3, plus 1 into SSI minus 4.
That's perfect. Correct.
And we can represent SSI minus 1 using SSI minus 1 alone. So this should be 1, 0, 0, 0. So 1 into SSI minus 1. And similar for SSI minus 2 and SSI minus 3. So 0, 0, 1, 0. So SSI minus 3, and this should be 0 into SSI minus 1, 0 into SSI minus 2, 1 into SSI minus 3, and 0 into SSI minus 4. So again, we can do a similar thing like we did in Fibonacci series. So we see that the sum, this is matrix raised to 1, and this is SSI minus 1. This sum is equal to I. Okay, so let's just copy this. So this is a multiplication. Okay. So let's write n here. This is n minus 1. This is n minus 2. This is n minus 3. So the sum should be n, and we know the value 0, 1, 2, 3. We can find the value 0, 1, 2, 3. So 1, 0. And we know that the sum is n. So this matrix should be raised to n minus 3. Correct. So this is n minus 3 multiplied by SS3210. So again, we can do a similar thing like we did here. So we'll call power, but instead now this matrix, global matrix A, should be this matrix 3 minus 2 minus 1 1. And again, yeah, like since we are calculating it modulo given number mod, so we will, whenever we multiply two matrices, we will do it modulo mod operation. So here also, since these are negative numbers, we will add mod here. So minus 2 plus mod and minus 1 plus mod in order to like do it modulo given number.
Can we write the code of that part where we are given input and we are finding these values? You can assume you have this power function.
Yeah, okay.
And you can assume you have the matrix multiplication function.
Okay.
in which blank matrix.
So SS int n, int A and B, which are the initial values, right? We should use the first four values. This should be A plus B. Let's write here. We need the first four values as base cases, right? Like we need to, whenever we get a matrix, we'll multiply it by these four values. So A, B, A plus B, and A plus 2B, 2 into B. This should be F. And
basically this.
S, yeah, this is F. S will be A, B, A plus B, 2A plus 2B, and then 3A plus 4B. To this, we are adding 2A plus 2B by A plus 2B, so 3A plus 4B. Again, we'll find the prefix sum of S to get SS, and this should be A, 2A plus B, add 2A plus B by 2A plus 2B, so it should be 4A plus 3B, 4 into A plus 3 into B, and then we will add 4A plus 3B by 3A plus 4B, so it should be 7A plus 7B. So let's initialize these values here. A, 2A plus B, 4 into A plus 3 into B, 7 into A plus 7 into B. Okay, so this is our matrix. B is Fn minus 3 because we need to find the power n minus 3 in this case. And to get the nth number, so we need the value at the first row. So this should be like if we've got this matrix, this should be A00 into SSI minus 1 plus A01 into SSI minus 2, A00 into SS of 3, A01 into SS of 2. So let's loop from 0 to 4. So this is answer, int answer equal to 0. For int I equal to 0 to 4 actually, I plus plus, answer will be bi. So b, we will only need the like first row, so b0i into ss of 3 minus I, because we are multiplying b00 by ss of 3, b01 by ss of 2, and b03 by ss of 0, so the sum is 3, so I and 3 minus I. And again we will do all these operations modulo mod. So okay, let's do it here. So since we are using integers, so it multiplication of two numbers which are greater than, which are of the order 10 raised to 9 will be of the order 10 raised to 18, which is outside the int limits. So we will write 1LL here, so it will change this number to long and there won't be any overflow issues. This modulo mod, and again answer modulo equal mod, so we'll return mod, answer.
Is it final from your end? Do you like to recheck it once, maybe?
Okay. Again, like we may have missed some base cases like we did previously. So let's check if n is the function is not defined for n negative, the f power function. So this is not f function, this is power function, and this is not defined for n negative. So if n is less than 3, then there is an issue with this code. So if n is less than 3, we can use the pre-stored values.
Correct.
Okay, so if n is less than equal to 3, we can include it or not, it doesn't matter because we have both here and this will return iota. So this should be return SSN.
Very good. One thing more I would like to suggest, I mean, can you see one more mistake? Is there one small mistake?
Okay, again, yeah, here we have to include mod as well. And so we may have to include 1LL here as well, because 10 raised to 9, like the limit of int is 2 into 10 raised to 9, something about that. So this may cause overflow here. 1LL here as well. Yeah.
One typo, I can correct this part. Okay, one question. Is it necessary to write 1LL, or can we just write 2LL and 4LL?
Yeah, we can write that.
Perfect. So what is the time complexity and set complexity now after the final solution?
So it should be, we are multiplying two matrices in 4q, so it should be 4q, and we will only require log n multiplications, or 2 log n actually. So 4 cube into 2 log n. It is order of log n approximately.
Yes.
So like if the matrix was of size k cross k, then it should be k cube log n. So in that case, this k cube term may be like more dominant in time complexity. But in our case, it is 4.
What is the space complexity?
So we are only storing matrices here. So it should be O1, but yeah, for calculating the power, we are using recursion. So we are pushing the like all the matrices on the stack, so that should be log n. Although we can write iterative power as well, function as well. So that will reduce the space complexity to O1.
But the recursive part is log n, right?
Yeah.
Okay, perfect. Very good. And we are done with our 45 minutes interview, I guess. So, few feedback. I mean, please note few things which matter in the interview really much. First, very positive point was that he was able to solve the complete solution. He reached the final log n time complexity. That is a really big plus point. Few small mistakes which can be improved are, I think, the formatting issues. We should have spaces between the operators and separators. Little formatting, but that's okay. Not a big deal. And I think rest everything was really awesome. So
someone is unable to reduce the complexity in the interview, what should be done?
Probably what your views on this?
So like you're expected to do that. So try to explain your brute force solution first, and the interviewer always gives you help, like hints as well. So if I wasn't able to come up with matrix exponentiation, so Kirsch would have helped me like to get it to log n complexity. So he would tell me about divide and conquer, like not divide and conquer, so dividing the power into 2 and representing the recurrence into matrices. So yeah, try to explain a brute force solution. So mostly interviewers like check your thought process, and if you're near to the solution, they will guide you to the solution.
And one small tip is there, like if you are stuck and you're not able to reduce the time complexity, then try to take small examples and try to do a dry run on them, and you will see some patterns or observations that can help you. That helped me a lot. This question is optimized by previous known techniques. If anyone doesn't know, then will the candidate be passed or not? So Akshay, in my scenarios, I was able to not solve it completely, that probability question in the whole Google onsite, but the rest 3 rounds were really awesome. So out of 4 rounds, you are just based on all the 4 rounds, not just one round. So if one round is not very well or very awesome, look, if another 3 are really awesome, I think you can be selected.
So like they don't ask the similar questions from fixed topics, so they ask questions from diverse topics. So you're expected to know at least some of them.
Yes. How to prepare for math? So Bobby, I think you are really good in math.
I mean, again, the same thing, yeah. So like I practice on online platforms like Codeforces, and some, like I also try CodeChef long challenges. They have some good mathematics problems. And if you want to like read something maths online, I think CP Algorithms is a really good resource to study. You can find amazing blogs. And
yes, and I think Project Euler is also there for maths if you want to start.
Project, actually, I didn't try Project Euler, but I won't recommend that as well. So they don't have like mostly like number theory problems, and that requires some lemmas. Hard problems are generally not really helpful. So you can try the medium ones, but mostly the hard problems I've seen, they mostly use some lemmas which won't help much.
How many years you have prepared for ICPC? So, Bhavya, when did you start your programming? I mean, in which year?
So we had an introduction to C course in first year, but I wasn't doing like competitive programming on online judges. So I started it in like second year. I was doing it. So I started with long challenges in CodeChef, and then moved to all the various platforms like Codeforces and all. Like short, I started with long challenges, and then as my speed increased, I moved to short challenges as well. And side by side reading topics on various platforms. So I don't think there is any less, like there are a lot of learning resources. You can just Google the topic and you will probably find tons of resources. And first time I qualified for regionals was in second year. So, and yeah, so we went to second year and we didn't perform really well in the online we did well in the online qualifier round, but we didn't do good in the on-site. And then I changed my team in fourth year. So, and this year we were luckily able to get it to World Finals.
What is the difference you think between second year and fourth year? I mean, obviously your experience of 2 years, but apart from that,
So like I had a different team as well. So there were different, I think, skill set as well. And yeah, exactly, experience as well. And maybe luck as well. So you have to be a bit lucky as well. Like you get problems which of topics you are strong at or something.
what programming language can you work with? Describe your experience with them. So, Bhavya,
Hmm.
I mean, how many
So,
programming languages are you comfortable in?
so I'm comfortable with C++, and so like if you are talking about competitive programming, generally people prefer C++.
Hmm.
Apart from that, like I'm familiar with Python for I've done some machine learning projects, and then like you can just learn it on the go. So I've learned AngularJS for internships and Java for like some project as well.
Hmm.
So like mostly you can in software engineering you can learn it on the go, I guess, because we are using different tools and technologies every day, and in that case, it's not like you will be working on a fixed technology for a long period of time. If you are talking about like competitive programming, I would say like I would prefer C++ because it has a standard template library, which is like you can write your code faster, and it's also fast, unlike other languages. It's probably the fastest. Like most platforms and even ICPC don't guarantee that your solution will work with other languages like Python, but in C++ it is guaranteed that it will work.
Thank you, guys. Thank you, Bhavya.
Thank you for having me.
So today we are going to be having a cracking the coding interview, a mock interview session, and I've invited a very special guest for both the interviewee and the interviewer are very special to me. I'll introduce the interviewer first, Utkarsh. Hey, Utkarsh. So Utkarsh has been a great mentor and instructor at Scalar Academy. Prior to joining Scalar, he had worked in Google, and he has been into competitive programming for quite long. He is ranked one in top coder if I take country ranking, and he has lot of achievements in the competitive programming space. You can see the thumbnails for his glorious achievements. He'll be taking the interview. The format of this particular interview is going to be a Google style interview. The way he would have given his interview in Google. That is the kind of format. The level of difficulty is also, similar to what you can expect in a Google interview. So, welcome, Utkarsh, to this interview. On the other hand, we have Gautam, who is in his second year and he is completing his computer science degree, pursuing computer science, and he will be the interviewee. He's been coding since since his 8th grade. He learned Java when he was in 8th class standard. So he's even though he's a second year student, it's almost 5 years since he started coding, and questions on trees and graph is something that he did in his 12th standard. So don't go by the number of years of experience or where he's currently at. He already has a 5 years of coding experience. So let's leave the stage for the two of them. I'll probably share the screen so that you guys can also see the problem. Over to you, Utkarsh and Gautam. So it will be a timed interview for 45 minutes, just like we have in Google as well. We might increase the timing a little bit because Utkarsh will keep on course correcting Gautam if he's going in the right direction, and we'll also give some hints. So might get stretched beyond 45 minutes, but we'll try to keep the mock interview for 45 minutes. All right, over to you, Utkarsh and Gautam.
Thank you, Mohit. So I guess the timer has started. Before we start, Gautam, can you introduce yourself first?
Okay,
Brief
thanks, sir.
introduction.
So I'm Gautam Arora. I'm a second year student at GL Bajaj of Institute of Technology and Management. So I have been learning Java since my 8th class, and right now I'm solving coding problems on different platforms like GFG and LeetCode. Also, I have been interested in web development, so I have been doing web development from my freshman year, and also I like open source contribution, so I contribute to numerous open source projects. And also I participated in GSOC this year, but unfortunately I couldn't get selected due to limited number of seats. Yeah, so that's all from my side. Over to you.
That's amazing. Nice. So let's start with the interview directly. And this is the question. I guess everyone can see the question now. So the question is basically we are given an array and we are given two integers m and k. Now there are multiple operations which you can do. In one operation, you can select any number of elements from the array and update them like this. So basically you can add anything in the array, but once the number exceeds m, we will take modulus with respect to m. And the is any number between 0 to k. It's up to you what you want to select x, and x can have different values for different element of it. So basically, if you select two elements of it, you can keep x equal to 3 for one element and x equal to 5 for two second element if k is greater than equal to 5. The goal is to find minimum number of operations to sort the array in non-decreasing order. So basically, we have to sort the array in non-decreasing order. This is our goal in minimum number of operations. Let's take example. So first example is this is our array. Here the numbers are m is 7, k is 1. So k equal to 1 means the x value can be either 0 or 1. Now, for this particular example, the answer is 2. These are two operations which we can do. So we can either, so first operation is we will select a of 0, a of 1, a of 2, and we'll select x equal to 1 for all three. So when we select a of 0 equal to and add 1 to a of 0, it will become 5 plus 1, 6. When we add 1 to a of 1, mod with 7, it will become 0. Similarly, when we'll add 1 to 6, it will again become 7, and mod with 7 becomes 0. And 3 will remain as it is because we are not doing anything. In the second operation, we take a of 0 and a of 2 and x equal to 1 again for both. So if we take add 1 to 6, it will become 6 plus 1, 7. Taking mod with 7 will become 0. Similarly, for a equal to 2, it is currently 0. We'll add 1 to it, it will become 1. So this is a non-decreasing array. Similarly, we have second example, 5, 6, 6, 1. In this case, k is equals to 2. So the values of x can be 0, 1 or 2. So in this example, we can solve it in one operation. We have selected a of 0 and added 2 to it, it will become 0. We have selected a of 1 and added 1 to it, it will become 0. And we have selected a of 2 and added 1 to it, it will become 0. So the final array will become 0, 0, 0, 3. Is the question
Okay.
clear to you?
Yep. It's
Any
clear.
doubt in the question?
No, it's clear to me. Yeah.
Great. So any thoughts that come to your mind?
Okay. So we are given an array of integers a and then two integers m and k, right? So we can perform one operation in which we have to select any number of elements in the array and update according to this expression. So what we can do is we can add x to any element and then mod it with m. So x value can be less than equal to k.
Okay.
So it is varying from 0 to k. Okay. And x can have different values for different elements of a. And now we need to find the minimum number of operations to sort the array in the non-decreasing order. Okay. So let's take this example, which is 5663, and we are given value of k as 1. So now what we can do is we can take x as either 0 or 1. Now what we can do is we are adding 1 to, so m value is 7, which is the greatest value, means the value of ai can range from 0 to 6, I guess.
We can also mention that initially all the values of a of I are less than equal to. So for all a of I, it is less than m.
Okay, less than m. So we need to find the minimum of two operations. So
The input also it's valid.
let's take a look at this example first of all. So we are adding 1 to a of 0, a of 1 and a of 2. So while adding 1, 5 becomes 6, this 6 becomes 7, and when I mod with 7, it becomes again 0, and this 6 also becomes 0, and this 3 remains unchanged. And so the new updated array is 6003. And now what I'm doing is I'm doing x equal to 1. I'm adding 1 to a of 0 and a of 2. So a of 0 added by 1, I'll get 0, and a of 2, I'll get 1. Okay, so I need to sort the order. So first of all, I'll try with a nice solution. Beginning with nice solution, what I can do is, so we need to sort the array in the increasing order. So what can be the next solution? I can
It's
start with the first
non-decreasing. Sorry, it's
non.
non-decreasing. Hmm.
Okay, so means we need to sort in the ascending order basically.
Hmm.
Yeah. So I can start with the first element. Okay, so first basically I what I can do is find the largest element in this array. So let's say the largest element is 6. So I can say that 6 will require least number of addition to become 0, if I would say like this. So 6 will only require 1 to be added so that it can become 0, and 5 will be requiring 2 to become 0. Okay, I need to find the minimum number of operations. Okay, first, can we find the maximum amount of operations required to sort this array? And so what I can think of right now is I can use binary search in a way where so basically I can find a search space for the binary search to apply on. So the search space will depend on the number of operations. So the minimum number of operations and the maximum number of operations required to sort the array. And if I'll get that range, I can apply binary search in that range to find the minimum number of operations. Okay. So what will be the maximum number of operations required? So the maximum number of operations required will be the equal to the length of the array, I guess, because so I think the concept for solving this question, though I'm not sure, is binary search on the answer. I'm not sure about that. So what binary search on the answer does is it applies binary search on the criteria. So what can be the criteria over here?
Okay, as you mentioned, if we calculate minimum number of steps and maximum number of steps to sort the array, so let's try to define them. So, can you tell minimum number of operations?
Minimum number of operations. Basically, we need to find the minimum number of operations only to sort the array. So maximum number of operations. So the maximum number of operations, I guess, would be equal to the length of the array, if I'm not wrong,
How it
because
is length of the array?
uh, for example, let's start with this element and try to make it 0 by adding. Okay, I can't add more than k in it. So see, let's start with this first element. So what are the maximum amount of operations required to make it as 0? It will be 2 operations, right? Because if I'll add 1 in the beginning, I'll get 6, and then I'll add 1 again, I'll get 0. So I can get 0 here by in by the minimum of 2 operations. So 2 operations for this, one operation. So now what I can do is, so basically all zeros is also a sorted array, right?
Correct.
What? So I can make each and every element as 0.
Yes, nice.
So let's say this. So the first array element requires 2 operations. The second element requires 1 operation. This 6 again 1, so 4 in total, and this 3 again
It's
requires.
not okay. When you mentioned 4 in total, what do you mean?
So
We are
means
adding.
what I mean over here is I'm adding. I need to. So basically, all 0 is also a sorted order. So what I can do
Correct.
is
That is correct.
I can apply some operations to make each and every element 0. So that will
Correct.
give us the sorted order. So the
Okay.
operations required for that will be 5, means ARR of let's say M minus ARR of I. Yeah, so 7 minus 5 will give us the number of operations required to make array of I as 0. Am I right?
Yes. In case k equal to 1, then it is correct.
Yeah, it's in case the k is equal to 1.
Okay. When we're discussing about minimum number of operations and maximum number of operations, it's like we are given any input and we have to return any answer. So, what is
Yeah.
the minimum answer we can return? for any given input, what is the minimum possible answer we can return?
Minimum might be 0, I guess,
Correct.
if
Yes,
array is
because if
already
we,
sorted.
yes, that is correct. So we get a minimum. What is the maximum possible answer we can return at any point of time? I mean, for any input in general.
Okay, so if the maximum number of operations required to would be, if let's say each and every element is,
0, as you mentioned.
yeah, okay, it's 0, so the minimum operations. Maximum number of operations, let me check. Let's say this element is 5. Okay, let's say if the array is in decreasing order, let's say the array is 6, 5, 4, 3. That's a
Okay.
decreasing order.
So there is
6, 5, 4.
5, 4, 3, maybe 2 or 1 also.
Yeah, 2 on 1, no problem.
Okay. And m is equals to 7. And for now, let's take a is equals to
Okay,
how? Let's
so
do this.
maximum number of operations required would be, so let's say 6 would be requiring 1, then 2, 3, 4. So I guess n plus 1 by 2 would be the maximum number of operations, and whereas n would be the length of the array, if I'm not wrong.
Are you sure?
6, 5. Okay, let's start with any array element. So basically, if the array is, so
Okay.
let's say m.
I'll recommend you to
Yeah.
read the problem statement again. Just try this reading once again.
Okay, so given an array of integers a and two integers m and k, for all I 0 less than equal, so this is the range of the elements. Okay, in one operation you can select any number of elements from a. Oh, in one operation you can select any number of elements from a and update them like. Okay, I think I missed this, where I can, in one operation I can select any number of elements, right?
Yes, correct.
So this is
So
the
now,
expression.
let's
Okay,
come back.
so maximum number of operations can be, let's say, if we can pick any number of elements in the array in one operation. So what, so let's say the array of length 6, and these are the elements. What, how would it be to pick only one element so as to increase the number of operations? In each operation I'll only select one element, that will increase my number of operations.
Yes, but
uh,
that will not be a good idea, right? And we would prefer selecting, because our goal is to minimize the number of operations. So would you
okay,
prefer selecting one element at a time, or you would prefer selecting two elements if there is option of two? So
okay,
in, let's
so
take this example. Let's take only this example, and let's say we have to find the answer for this. What is the answer for this particular input?
okay, so m is 7 and k is equal to 1. So x can be varied from 0 or 0 and 1. So the x can be equal to 0 or 1, right?
Does
So
x equal to 0 make sense?
no, actually, because if I'm adding 0 to any element, there won't be any change, right?
Correct.
So that doesn't make any sense. So x, let's take x equal to 1 in each and every. So let's start with this array. In first operation, what I can do is I can add 1 to this, add 1 to 6. So 6 will become 0 because it's modulus by 1, it's modulus by m. And what I can do is I can add 1 to 5, so it will become 6. And I can also add 1 to 4 to, so that it could become 5. It's actually 5 if I'll add, and now it's 3. So now the question arises, should I add 1 to 3 or not? Let's say we add 1 to 3 as well. Okay, let's try with adding all elements. Add 1 to each and every element. So what it can do, what it can become is 0, 6, 5, 4, 3, and 2. Now the array becomes 0, 6, 5, 4, 3, 2. And now what I can do is I can add 1 to element starting from ai, from index 1 to n minus 1. So the next 6 6 becomes 0. The 6 becomes 0 now, and this 5 becomes 6, this 4 becomes 5, and this similarly now I'll add 1 to starting from index 2 to n minus 1. So the operations which number of operations which I'm getting is one operation over here. Am I getting the max number of operations equal to the length of array for this case at least?
In this case, if we are doing this, then how many operations will it take?
So in first operation, I'm getting
1
0
0.
over here. Yeah, in second, I'll get 2 zeros. So
Third,
in n operations, I'll get n zeros, and that will make it okay.
you need 6 operations.
Yeah, for this case, we need at least 6 operations.
Okay.
Uh, Now, what will be the maximum number of operation? The question is still in my mind.
Now let's do this. Let's remove this, and let's remove this, and let's remove this also. Now shall we do one dry run on this?
Okay. So now the array is in descending order, as I can see. What I can do is I can add 1 to the first element. It will become 6, 3. Okay, I can add 1 to each and every element so that it can become close to m minus 1. So I'll add 6, then 4, and then 2. And now I'll again add 1 to each and every element. It will become 0, 5, and 3. Now what I can do is I can add 1 to elements starting from index 1 to n minus 1. So it will now become 0, 6, and 4. Now again we'll add 1 to each and element starting from index 1 to n minus 1, and it will become 0, 0, and 5. Now I'll add again 1 to the last element. Okay, now
Do
the
we
array is
eliminate?
sorted. So no, we don't need any operations. Oh,
In this case, we took how many operations? 3 or 4?
we
We
took
took 4 operations.
yeah,
But it's
first
greater than
operation.
the array size.
Okay, it's greater than array of size. Yeah, yeah, it's greater.
So do you remember you mentioned that if we make every element 0, then we can get our answer. That's totally good. That's totally good observation. How many
Okay.
operations do we take to make this particular one 0? Or any one if we are given in the array and we have to make that one equal to 0, how many operations will it take?
Okay, so if any element is 1, we'll take, if it also depends on k, I guess. Yeah. So it depends on k. So let's say this, for this case 1, we'll take m minus k. So we'll take 2, 3, 4, 5, and 6. So I think we'll need m minus k operations to make any one as 0.
M minus k. How is
Yeah.
that?
Let's say, oh no, minus won't work. Let's say if it's,
Let's say we have m is equals to 8. And let's say we have k equal to 2. Now, if
so
we have a
let
1, how many
yeah.
operations will it take to make
So
in one
one will,
operation?
I'll
Hmm.
get 3, and then
Hmm.
I'll get 5, then I'll get 7, and when now I'll add 2, I'll get again 1.
But you can add 1 and make it 0.
Yeah. So the operations required would be m divided by k.
And will it be floor or seal of this? So it can be a boolean. Also, it can be a decimal number.
I guess it will be the floor, because yeah, it will be the floor, because let's say there's one over here and I'll add two on each iteration. One, it goes to 3, 3 goes to 5, 5 goes to 7. Now I'll
Let's make it
get,
3. Now, let's try on this. M8K3.
okay, so 1 will become 4 after adding 3, 4 will become 7, and now I'll add only 1 so that it could become 0. The number
Now,
of operations are one, 3 operations, right?
correct. So, if
So
we take
the,
8 by 3 floor, it will become 2. And
okay,
if we take
so
seal,
that,
it will become 0.
yeah, so I think seal will work over here.
Hmm, correct. And Can we say this is also the maximum number of operations we need?
For the one, are you saying for one?
No, for any answer. Answer can never
Okay.
exceed this particular value. Can we say this statement?
Yeah, we can say, because if it's 0, we don't need to do anything, and if it's 1, yeah, I can say that seal by m by k would be the maximum number of operations required for any element
Very,
to
very
be.
good. So we got our range
So
of
we got a
answer.
range
Yes, as
0.
you mentioned. Yes. Let me
So
just copy it.
now I can think of applying binary search over here, because we have got the range. Okay, so let's say the initial binary search, we can take mid as 0, low plus high divided by 2, which is initially the binary search algorithm. And I'll start with the mid and check that can the array be sorted in the operations which is equal to mid, right? So let's say
Yes.
if this is the array 5663 and the mid is, let's say, x, so now we need to check that this array can be sorted according to this expression in x number of operations. If yes, we'll go to the left hand side to find the minimum of that, and we'll store x basically. And if it's not the case, we'll move to the right hand side.
Yes, very good, very good. So let's write the new question now. Now the question is updated to check if we can sort the array in, let's say m mid, or what do you want to call it?
Mid will
Width.
be fine. Yeah.
This is our now new strategy. So let's take this example and let's make k equal to 2. Now try and
Okay.
think how we can solve this question.
So a equal to 531 and m equal to 7 and k equal to 2. Now, so first of all, low will be equal to 0, and high will be equal to seal of 7 divided by 2. Am I right? Mm,
3.
no. What I'm confused about is seal 7 by 2 will be the. Okay, yeah. So seal, yeah, I got it. So high will be equal to 4 for this case. Yep.
Yes, correct.
So mid will be equal to 0 plus 4 divided by 2, which is equal to 2. Now we need to check whether this array can be sorted in two operations or not. And in each operation, we can take any number of elements and try to make it as 0. Yeah, so let's say I'll start with the element 5 and start making, I'll add 2 to it so that it becomes 0.
Why do you want to make it
And
0?
what's
Why do you prefer to make this particular 5 0?
because if 5 will be 0, then I can surely say that this part of the array will be sorted, because the element can't be negative.
5 is also sorted.
But the
I
range
mean,
of elements in the array can be so from 0 to m. So if it's 0, I can surely say that the left part is currently sorted.
but the left part currently is only a single element. So no matter what element it is sorted already. So if you are standing at
Okay.
the first element of the array and you
Okay.
say that, okay, make it 0. What is the idea? Why we are preferring to make it 0? I mean, is it required? Is it not required? If required, then why it is required? That is the question.
Okay. So now the question is, why we need to make the element as 0, or or is there any need to make the element as 0?
Yes.
Okay, so let's say if the uh, element right now, let's say the pointer is at 5, and we check for the next element, the element immediate right element of I, and if it's less than the current element, we'll need to make it smaller than this, right?
Okay, so for every
Yeah.
element you are checking the right hand side, but we are traveling from left to right. So maybe you may prefer updating 3 instead. No? Yes. I mean,
Okay.
we are not sure we will update 3 or not because we are currently standing at the first element, and I think you are traveling from left to right. Is that right?
Okay. Yeah, I got it. Hmm. Or we
I mean,
could try with.
Your idea is correct that we can make first element 0. My question is, why is that idea we are selecting? Why we are making first element 0 and not keeping it as it is?
Okay. Why are we not making the first element?
I mean, it is also possible that it may be not possible to make it 0. If the first element, let's say, is 1 and
Yeah.
we have number of operations 2, then we can make it at max 5. We cannot make it 0.
Okay. Yeah. I got it.
So the question is still the same. If we are making it 0, then why making it 0? And what will happen if we cannot make it 0? The idea is correct that making 0 is good idea, but why? That's the question.
Eventually we want that each and every element at the right hand side would be greater than the current element.
Correct.
So if let's say the current element is 5 and the next element is 3, uh, I want this element to become, or what I can do is I can perform some operations to make this 3 greater than 5, or I can do some operation to make this 5 less than 3.
Right. Let me tell you why it is true. I mean, your idea is correct, but let me explain why. If we make it 0, then when we travel right hand side, that is, we are moving to the second element, at that point of time, we have more options. So let's say if we are not making it 0, it is 5, then when we are at this particular element, we only have option of either making it 5 or 6. So if we are able to make it 5 or 6, then we are good. If we are not able to make it 5 or 6, then we are, we say that we cannot do it. But if we are able to make this particular element 0, then for the second element, we have more options. We can make it 0, 1, 2, 3, 4, 5, and on. Now the second part is that what if we cannot make it 0? If we cannot make it 0, for example, if this is equal to, let's say, 2, the best we can do is make this 2 equal to 2 plus 2, 4, and then it 6. And 6 will be a very high number. So making it 6 will not be a good idea, because now for the element on the right hand side, we can only make them 6. We don't have any other option. But if we let it be 2, then for the element on the right hand side, they can be either 2, 3, 4, 5, or 6. So we prefer that the element which we are currently standing at is as small as possible, which we can make, so that we have more options for the elements which are on the right hand side. Is that making sense? Oh, sorry, let me repeat. So when we are currently standing at this particular element, let's say we are traveling from left to right.
Okay.
Now, if we are standing currently at 5 and we leave this 5 as it is, then when we reach particular
Okay.
3, we don't have any choice but to make it either 5 or 6. The only elements which it can become is 5 and 6. Similarly, 1
Yep.
only has a possibility of becoming 5 and 6. So elements on the right hand side, if there are more elements on the right hand side, they can never acquire any value less than 5. Either they will be 5 or they will be 6. But if we make this particular element 0, then these elements can take any value 0, 1, 2, 3, 4, 5, 6. Similarly, this also can take any value. I mean, obviously, when we will reach 3, we will make sure that the right hand side element of that this particular 3 should be greater than left hand side. So when we will reach 1, we will make sure this particular 1 is greater than the elements on the left hand side. But if we make sure that the current element we are standing at is as small as possible, it opens up to more options on the right hand side.
Yep.
Is it making sense? So, okay. So we'll make this particular 5 as 0. That is good. So this 5 became 0. Now what we'll do?
Now what I can do is I can leave 3 as it is.
Plus 2 mod 7 is equal to 0. This is the first one. So we are leaving
Yep.
3 as it is.
Yep. So now the last one, I need to make it greater than 3. So I can just add 2 to it. So it will become 3. So hence our array will be sorted.
Yes, that is correct. So we came to know that with 2 operations, we can solve this particular question.
Yeah. Now we need to go to the left hand side,
Okay.
because we know we can
So
solve the question.
this
We'll
row will now
basically,
become.
so the high will now become 3. Sorry, the mid was 2 earlier, so now high will become 1, and mid will become 0 plus 1 by 2, which is 0, which is not possible. So now the question arises: can the array be sorted in 0 operations? So it is not possible until the array is itself sorted.
Correct. Very good.
So hence we can be sure that our answer is 2. We can return the answer as 2.
Why we have not checked for 1 right now? We checked for 2, we checked for 0. Still
Oh.
low is less than equal to high. If we say that it is not possible, we will have to update low
We have
pointer
to move.
since
We have to move to the right hand side. So now low will become 1 and high is equal to 1 and mid will also be 1. Now we need to find whether this array can be sorted in one operation. So if we try to make it as 0, the first 5, it will become 0 in first operation, and this 3 will remain at it as it is, and again 1 can be become 3, and yeah, the array is now also sorted. So we can return, now we can easily return the answer as 1. So the minimum operations required to sort this array is 1.
because after this, if
So
we try to make this, it will become 0.
yeah, so when low has now bypassed the high, and now we'll stop our binary search. So now we say that for this particular problem, I need to make first element as 0 so that I can get maximum number of opportunities or cases to make the array sorted at the right hand side. Can I say that?
Yes.
Okay.
Okay. So the idea is more or less clear to you. Let's write the code for this particular part only, where we are checking whether we can sort the array in any number of steps. So
Okay.
the now question is check if we can sort the array in, let's say, d steps, and the input is array m and k. So you can write a function below this in which these three are parameters, and you have to return true or false. Just write the code for that part.
Okay, let me try. So let's make static boolean. Let's make is possible as the function name. It will take array as arguments int m and int k. So now we need to find whether this array can be sorted in d steps, uh, and what will be
D,
d?
D is also,
Uh,
let's say, one of the parameters.
okay, int d. Okay, so now what I'll need to make the first element as 0, right? I'll need
But
to
it
make
may
the
be possible that it cannot become 0. So you have to make sure of those cases.
okay, the edge case for this is it can't become 0. Okay, so what I can do is if it can't become 0, I'll just make it lesser than I can make means what I can do is I can make this first element as closest as 0 so
How
that
will
I
you do
can get
that?
uh,
I mean, if we add anything to it, it will become high, a higher value.
yeah, but I'll be doing the modulus operation each and every time by 7 also by m.
I mean, if any chance, once if we are able to reach m, we'll obviously make it 0. Why not making it 0? If we are able to make any element a of 0 equal to m by adding some numbers, then we will always prefer to make it 0, right? We will not prefer to make it anything higher than that.
Yeah, yeah.
But if we are not able to even make it 7 or even make it m by adding some numbers, then what we will do? I mean, the idea is correct that we will try to make it as small as possible. Now, if we add anything to a number, it obviously becomes a higher number,
Yep.
and we are unable to reach the modulus operation. So why not let it be what it is currently? What do you say?
Okay, so if I'll make it stay what it is, so let's say if the array, let's take for this case, let it remain as 5, and what I'll do for this is I'll add 2 in the first operation. I'll add 2 to this element, and I'll add 2 to this element, but it will not serve our case.
I mean, we first have to write the condition to check whether it is possible to make it or not. So try writing the code of that part, the checking part. How will
Okay,
you
so
check
what?
whether the we can make the current? How we can check whether we can make the first element equal to 0 or not? Just start with
Okay.
that first. Then we'll see how it goes.
So let's say k is 2 and m is 7. I'll keep on adding 2 to 5. So I can start with the loop, I guess, and let's say, and I'll keep on iterating the until the k reaches ARR of I reaches 7 or not, 6 or not, m minus 1. And if it becomes m minus 1, or see, if it is 5, by I can add 2 to it to make it 0. In this case, I can add 2, which will become 5. So let's say the element is 2, and I'll add 2 to it to make it 4. Then I'll add 6 to it, and then I'll add 1. So I guess any element can become 0. It is possible for any element to become 0 eventually.
What about if this is 2?
If this is 2, okay, so I'll add 2 to it to make it 4, and then I'll add 2 again to it, make it 6, and then now I'll add 1 to it to make it 0. Yeah, so I think the element will, any value can become 0 eventually.
Yes, but we have a limited number of steps. We have D steps only available to us.
Okay.
So let's say if in this particular case, let me just update this. If we have D is equals to 2. Now what we'll do?
So the basic question now is, can we make any element as 0 in D number of steps, right? So if the gap between m minus 1 and array of I is greater than
In this example, is it clear that we cannot make this to 0?
no, we can't
Yes
make
or
it
no?
in two operations.
Correct. Very good. So what is the condition you will write to check whether we can make it 0 or not? Let's skip the code part for now. Let's say we don't want code. We just want that condition. And that will be
Okay,
all.
so first we'll
So,
find the gap between the m minus 1 and 2. So the gap in this case is 4. And if the gap divided by k, so what I can say basically is, if the gap between m minus 1 and ARR of I is greater than or equal to the multiplication of k and d, I can say that it can't become 0. Am I right?
yes. So please repeat once.
So what I was saying is, if the gap between the m minus 1 and the ARR of I is greater than k and d, multiplication of k and d, I can say that
Correct.
it can't become 0.
Yes, that is correct. So can you write it down? Just that. And we will do this.
Okay. If the gap between m minus 1 and ARR of I is greater than or equal to k into d, I can say that the value can't become 0.
Why we are writing m minus 1 minus a or I?
So ARR of I basically means the value of the array element at particular index.
If we take this example, then m is 7. So if we take 7 minus 1, it will become 6. If we do 6 minus 2, it will become 4.
4.
So 4 is equals to 2 into 2, 4. That is true.
Yeah,
But
so
we cannot
I
make
can
it.
say, yeah, so that if this condition is true, I can say that it can't become as 0, because we need the gap to be fulfilled by k into d, means we need to make the gap fulfill, right, so that it can become to 0. So it must surpass the limit of k and d.
Are you sure? 6 minus 2, 4. We cannot do it. If we write it 3, then 3 plus 2, 5 plus 2, 7. Then we
Let's
can
try
make it
for
0. So 3 will become 6 minus 3, 3. 3 is greater than equal to 2. No, so we can make it. And if it is 1, 6 minus 1, that is 5. Okay, this makes sense.
So this means we can, this condition says that we can't make an element 0 if this condition is satisfied.
Because for 2 is equal, and for 3 we are able to solve it.
Yeah.
This is good. So let's end the interview for now.
Thank you so much for the interview, Utkarsh and Gautam, both of you. I think the solution, we are going in the right direction. You would be able to, given more time, you would be able to think through the solution and code it out as well. So Shivam has a observation, time complexity is n into m.
We can fix last element and then we can just try to make each preceding element smaller than equal to fixed element and fix it. Brute force to this last element this time. Observation is very correct, Shivam. So basically in the interview we were trying to go left to right and I think Shivam is trying to go from right to left. So if we do this, we'll try to make the current element as high as possible. And this is about complexity. And in turn, we can reduce it a little bit if you do little observation, Shivam. But this solution may work. That is true.
Then Vineet was when you were asking question around what would be the maximum operations. He started off with m into length of the array, and then I think Smith was correct in pointing out it will be m minus a of I by k.
Divided by k. Yeah, that is correct.
For a generic,
Because we can-
like, correct. So
For generic k, yes.
yes,
In the worst case, we are making it equal to 0, so it will be that.
correct.
The observation is correct, Vineet, but in this case, we don't need to make one less than that because we have non-decreasing array. So even if all the elements are equal, we are good.
Correct.
The current less than number on right, then make current equal to index or number in the right, whichever is greater.
I think this is the answer to the question when you're saying when should we make the leftmost element equal to 0. So
Okay, so Vineet is trying to compare with the right hand side element.
yeah,
But if you're traveling from left to right, then it's not a good idea to compare on the right hand side element because eventually we'll update the right hand side element. If you're traveling
Correct.
from right to left, then this observation is correct because we'll not update the right hand side element.
and I think the last statement where you were asking Gautam to write the code, what should be the condition? This is his answer, Sudhanshu's answer.
This answer is correct because we can
It's
add
correct.
max k into d and of elements. That is correct.
Yeah,
So basically, till the part of binary search, that was awesome. I mean, Gautam did an awesome job of figuring out that we can solve it using binary search because that is now the question is easy for us to solve. Now the question only remains is to check whether we can sort this particular array in mid number of steps. If we are able to sort in mid number of steps, then we'll try to decrease the value. So we'll make it L minus 1, sorry, M mid minus 1. Otherwise, we'll make it mid plus 1, the right hand side. So let me write the code for it and I'll explain. So we'll make L is equals to 0, minimum number of steps. We'll make I is equals to, I usually write ceil like this, M plus K minus 1 divided by K. This is also one of the ways of writing ceil M by K. While L is less than equal to I, now equals to L plus I by 2. I can write L plus I by 2 because L and I are not very big numbers. In case they are big numbers, we should prefer writing it like this. L plus I minus L by 2 so that we don't have any overflow while adding L and H. Then we need to check whether we can solve it in this particular steps or not. So let's take a variable last, which is saying that currently we can make our element equal to 0. 0 is a good element. Now we'll have for and we'll take a boolean variable can equal to scan is a boolean variable which tells whether we can do it or not. Right now I'm assuming we can do it. So for n is the size of the array. Now we have to check whether we can make the current element equal to 0 or not. So if the current element is a of I plus number of operations we can do is mid multiplied by k is greater than equal to what we have is m also given in the input. Then we can do it. Otherwise we cannot do it. So if we are able to do it, what we'll do is we'll just update a of I is equal to 0 and we'll keep last equal to 0 only. So last will remain as it is because next element also will try to make it equal to 0. If we are not able to do it, then what we'll do is we'll keep a of I as it is. We'll make last is equals to a of I because the next element should be at least a of I. Now there is one more condition. If the current element is not the first element, that is if I is greater than 0, then we also have to check whether the current element can become at least what the previous element is. So we'll not write last over here, we'll write last after this. Because if we are not able to make the current element equal to the previous element or greater than the previous element, then we are unable to make or find the answer in min number of steps. So now our goal is to make this particular formula, like reuse this particular formula. So if the current element is of I plus made into k is greater than equal to the last element, that is the previous element right now, then we are good and we don't want to change anything because, oh sorry, we'll just try to make it equal to a of I equal to last. Otherwise we can say we cannot do it and can will become false and we break out of this. And once this else condition is complete, we can complete the for condition. There's a if condition, if it is true we'll go there, otherwise else के अंदर ये if है, if के अंदर ये if है, else के अंदर ये statements हैं, and equal to this and we break it, and this is the if part. This makes sense, right? Now यहाँ पे क्या ये for loop complete होने के बाद we'll check if we are able to make it, then we'll try to reuse the answer. So since we have to find minimum answer, so we'll try to make h is equals to mid minus 1, else we'll try to make L is equals to mid plus 1. Once the while loop gets completed, we'll have to return the answer. So now the answer will be stored in the element. Say if we are unable, when we were able to make it, we are able to make it h equal to mid minus 1. So h plus 1 is the last element which will store our answer. This is what we can return as our answer. We can even have a variable answer which will store the answer equal to mid every time we hit a can. Then answer will also remain the same. But the main idea was this particular part. If we are able to make it, we'll make it 0. If we are not able to make it, we'll check, can we make it equal to the previous element? If yes, we'll make it equal to the previous element. If no, we cannot solve the question with this particular number of operations.
Shouldn't it be more than, like we shouldn't try to make every element more than equal to 0, right? Because if we have a previous element for whose example, for example, if you consider 1 0 0 0 or 1 6 something like that, 1 6 3, M is 7, M7 K 2.
Okay. Let's run on this.
Yeah.
Yeah. Okay. L is equals to 0. H is equals to 4. M by 2. CL is 4. Then we'll have mid right now is equals to 2. So the for loop runs. We'll check if A of 0, that is 1, plus it is 2 multiplied by k is 2 is greater than equal to M is 7. But if it is okay, it will only work in case of the previous elements. Yes, we should not try every element to make it equal to 0.
It should be actually last, greater than last.
Sorry. It is last. Last, then this condition is not required. If we are able to make it equal to last, greater than equal to last, we'll make it equal to last. If we are not able to make it equal to last, then we cannot solve it. Yeah, say. This is fine.
Option says it's a bouncer. So it's not a bouncer, right? You just keep practicing such kind of questions. It is, I'd rate this somewhere in the hard difficulty, if I'm not wrong, of this particular question. It is hard, right? Right. So finding out, first of all, it's a binary search problem. That itself is hard. Gautam did a brilliant job in finding that out, that hey, we can apply binary search to solve this particular problem. So difficulty is definitely hard. So Vineet has another question, that which companies would ask questions of such kind of difficulty or in this kind of a format?
Google or Facebook, I'll say.
Yeah, so any farm company, right, which is primarily a DSA, who which primarily hires based on your performance on DSA rounds. You can expect such questions in those kind of companies. Any feedback that you would want to share, Gautam, with us? How was your experience?
So it was a great opportunity for me to get a live mock interview with Utkarsh sir. Thank you so much for that. And I really loved it. It showed me the path where I need to focus on more to get a job at FANG.
All right. Any things that you want to suggest, Utkarsh? Maybe what are the things that he can, go back and look at, so that he can improve upon his DSA skills? You have been a competitive programmer, right? So is that the only way to, if somebody has to crack FANG, so it should he, go and do competitive programming, or are there any better ways?
I say best is practice. That's the only way you can improve on computer programming. For interviews, computer programming is an advantage, but not a prerequisite. So I would recommend you to solve most of the interview questions specific to the company which you are targeting. Let's say if you are targeting Google, try to solve the questions which are asked in Google. You can find it online. I mean, we have a lot of platforms where you can find Google tagged interview questions and try to solve as many questions as possible. That's the only tip which can help. I mean, there is no shortcut to success. That what I can say. Some people say that let's practice only one particular topic and hope that will come in the interview. That's not a good idea.
Solving the challenges and being regular in solving those challenges, right? Solving problems on any platform, I would say, not just interview, but right, any platform. Go there and solve the problems in a timed manner, right? Because timing in an interview is everything, right? If this was a real Google interview, you would be expected to not just answer the code, but write the complete solution as well.
30 minutes is an upper bound on the solution explanation part. If you are unable to explain it within 30 minutes, then you can assume like your interview is not going very well. But if you are able to explain the complete solution in 30 minutes, then writing the code in 15 minutes is very easy. The interviewer will not expect you to write very detailed code. If you are only able to write a small piece of code, like a sub problem, like in this example, the actual question was a binary search on answer, but the interviewer may expect you to write that part where you have to just check whether you can solve or sort the array in these steps. That code is also good enough because binary search is just 2 or 3 lines above and below.
Cool, guys. Let's wind up. Bye bye, guys. Thank you, everyone.